Bristol Community College, Mathematics with Dan Avedikian, Math 131, Elements of College Mathematics, Section 2.1, Problem 15. This is number 15 from Section 2.1. Solve the system of linear equations 4x minus 6y equals 10 and 6x plus 9y equals negative 15. So what we'd like to do is multiply one or both equations times some values so that one of the variables will have the same number in front but with opposite signs. So with the x's, we could really, if I have a 4 and a 6, I could do 12x and negative 12x. Or the negative 6y and 9y, I could make 18s with those. I could go negative 18y, positive 18y. About the same either way. You should get the same answer either way. A little smaller numbers with the x, so I'm going to choose to cancel the x. No special reason. It should work out the same either way. So if I'm going to make this into a 12x and it's currently a 4x in my top equation, everything will have to get multiplied times 3. So 3 times 4x is 12x. 3 times negative 6y is negative 18y. And 3 times 10 is 30. Now the bottom equation, if I want to match up with a negative 12x, right now I have a negative 6x. So to make it a negative 12x, I'll do times 2. So the bottom equation, everything's going to go times 2. 2 times negative 6x is negative 12x. 2 times 9y is going to be 18y. And then 2 times negative 15 is negative 30. So step 1 is now complete. Oops, I said 12 and I didn't write it. I'll fix that. So what I have is the same number but with opposite signs in front of the x. But also the y and also the right-hand side. So for step 2, where it says add the equations together to cancel one of the variables, you certainly do cancel one of the variables. You cancel the other variable too, and you cancel the right-hand side of the equation. You wind up with 0 equals 0. That's true for all values of x and y. And again, your first reaction to that might be, oh, I must have made a mistake. But that's not necessarily the case. What you have here is a problem with infinitely many solutions. So how can you have infinitely many solutions? What's going on? If you saw the graph of this, one line is right on top of the other line. This is what you call coincident lines. So when you say that there are infinitely many solutions, it's not that any point is a solution. Any one of the infinite number of points along that double line is a solution. So a point out here would not be a solution. Any one of the infinite points on the double line would be a solution. So you have infinitely many solutions. And some books write this in a variety of ways. For this class, if you say infinitely many solutions, that's enough of an answer. But they will assign, what they say is you can let y be anything you want, and then based on that, you can figure out what x would be. So you get to choose a y, they call that a parameter, and you can figure out your x. So some books will say pick an x and you can figure out the y. Essentially, it's the equation of one of the lines. But you have an infinite number of solutions.